Question 3 will be based on vertical projectile motion. And again, when you do your questions on Friday, please do not forget to write this statement that says, I can solve this problem. The I stands for interpretation of the problem. So before doing any question, interpret that question. The interpretation involves reading the question and analyzing the given information. Information can be given in the form of tables or graphs. And I can see in this question we have a graph. So we have to do some analysis around that graph. Let's begin with our problem interpretation. The problem reads as follows. They say a velocity versus time graph of a ball thrown vertically upwards is drawn below. Then they come and say ignore effects of air resistance. Now when we look at this graph, we can see that the object starts moving, or our ball starts moving vertically upwards with -5 meters per second. That is the velocity. And this happens when the time is 0 here. So at t is equals to 0, right? At the initial instant, we have an initial velocity of -5 meters per second. After some time, we can see that our velocity actually decreases to a number that is less than 5. Remember that the negative only shows direction, so any number that is above 5 will be small in this case. Then as the time goes on and increases, we see that our velocity decreases, right? It's getting smaller and smaller and smaller, right? Until such a time where we reach this point here, right? At some later time here where the velocity becomes exactly 0, right? Now this is a typical situation with vertical projectile motion where there is no air resistance, because we expect our velocity to get smaller and smaller until we reach the maximum point where our ball will stop for an instant before it changes direction and goes to the other direction. Now this means as we continue past this point here, we will come to this time. The time will continue increasing as the ball is now it passes the maximum point. But look at now, we start having a positive velocity, and this velocity moves from 0 and start gaining or regaining the amount that we were losing. As the time increases again, we start increasing the velocity and increasing the velocity and increasing the velocity, just like that. At some point on this path, we'll go back to 5 meters per second. We'll have the same velocity we started with, the same speed we started with, not velocity, but in the opposite direction. So the velocities are not the same because the other one is in the positive direction and the other one in the negative. But the speed is the same. The magnitude of the velocity is the same, right? So I don't know if this would be this point or it will be below that point, because we are not told. Maybe the question will guide us as we go along. So what are we having here? We are having a situation where a ball is thrown vertically upwards with a velocity of -5 meters per second, and this ball will go upward like that until it reaches the maximum height here where the velocity is 0, and it will come back and regain all that velocity, right, until it comes back. I don't know where it will end. They say here the ball is thrown from the reference point, right? When they say the reference point, what that means is that the ball is thrown from the origin. So origin means the starting point, right? Where we start measuring our position to be 0. So this means at this point here where the ball is being thrown, it is 0 meters. That's where we start doing our measurements in terms of position, displacement, or distance, right? Now, one thing that also you have to note in this problem is that this graph automatically has determined the direction for us, because we can see that the velocities that we have in the upward path, right, in the upward path here, they are actually negative. It's -5 and getting smaller like that as a negative value until we get to 0. After 0, we start seeing positive values. So this means now that our direction from this graph is chosen such that going down is positive, or rather going up is negative, right? So that is what I can interpret from this problem. So I'm done with problem interpretation, right? Problem classification will always be the easiest to do, because we know that our question papers are arranged according to the topics that we do. We know that question 3 will always be vertical projectile motion. So this problem, even after interpreting here, I can see that it's a vertical projectile motion problem, right? So it will involve the use of the 4 equations of motion, and this question can come in a form of graphs. Sometimes it can come in a form of you having to draw the graphs yourself, right? So now we have classified this problem as VPN, right? It is possible also to classify this problem as one that uses the law of conservation of mechanical energy. In other words, we can use work, energy, and power here, right? So if you like, you can explore those options and see where they lead you, right? Now we are ready to jump to A. A means answer to the problem. So we're going to answer the problem. Now we go to the actual questions and answer the problem. And we should be able to answer the problem because we have already understood and know what's going on in our problem, right? There are 2 questions that we'll always get in the physical sciences. Questions that focus on concepts. So this would be questions that ask you to give brief explanations, state laws, right? And the other questions are calculation problems, right? So 3.1 says to us, is the ball in free fall? Choose from yes or no. Give a reason for your answer, right? Definitely this ball is in free fall, right? I hope we all know that. If we don't know, or maybe forgot, this is a great opportunity to remember or revise that. So the answer here is yes, right? Why do we think that the ball is in free fall? Because the ball is, or let me say, the ball moves instead. Because the ball moves in the absence of a resistance. Therefore, the only force present is the gravitational force. Right? That's how we know that it is in free fall. The only force that is present here is the gravitational force. There are no any other forces. There are many other ways in which you can answer this question so that you can score your 3 marks. So they'll give you 3 marks for answering this question, right? The other way in which you can answer this problem or this question is that you can say the ball moves under the influence of the force of gravity only, since there is no air resistance. I mean, it's the same thing but are restructured differently. Or you can say the ball is in an isolated system, right? Or you can say the net force is 0, right? There are no external forces, right? Those are other ways in which you can answer this question. Now, question 3.2 says calculate the maximum height reached by the ball, right? So we want to know, remember that this we said is 0 height, right? So from here, if we measure from here our height, if we move from here to here, what is the maximum height. What is this height here? Because remember, the ball ends only up to here. It does not pass this point. It's the maximum height that it will ever reach, right? So we want to know this height here. I'll call it change in y. What is that maximum height? Remember always that to use equations of motion, you need at least 3 physical quantities on our equations to be able to choose any one of those equations to solve the problem. Already I can see that I have an initial velocity, I have the final velocity here, and also always, even if they don't tell us, we know that we have g given by 9.8 meters per second squared, 9.8 meters per second squared. And in this case, our 9.8 is positive. Why? Because of anything that goes down is positive according to this graph, and anything that goes up, right, is negative. Right, so our 9.8 is positive. Very, very important to be able to see that. The graph will always determine direction for you. The way they draw a graph will give you the direction for your projectile, right? So to answer this question, 3.2, we will then choose an equation here. 3.2, I can choose the equation that says the final velocity squared is equals to the initial velocity squared plus twice the acceleration due to gravity times change in y. So that I know that my final velocity is 0 squared, and my initial velocity is negative 5 squared plus 2, 9.8, right? Again, it's positive. I can't emphasize that enough, right? And then we're looking for change in y. From here, this problem is very, 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 very boring, because we'll use our calculator to then say now, the 5 squared is equals to 25, right? So I'm going to get a 25 here, which I'll take to this side, so that I have 25 is going to be a negative 25, because remember, when I square this is going to be positive 25, right? So that this side, here is just a 0, right? So that I'm left now with 2 times 9.8, 2 times 9.8 is equals to 19.5, right? So this one here gives me 19.5. So this means our height, or rather our displacement, would be, I'm going to divide here by 19.5 and 19.5 as well. This side, the 19.5 would cancel, right? Now on my calculator, I will have negative 25 divided by 19.5. And my answer comes out to be a negative 1.28 meters. Now, what we have found here is the displacement. And displacement, remember, it's a vector quantity. So it's telling us that we have a vector that goes from here to here, right? The change in y to be negative 1.28 meters, right? But now we are looking for the height, and height is a scalar quantity. That means we only want the magnitude of this displacement. So to answer our question, we will say then that the maximum height is 1.28 meters. Now this is your answer, right? If you leave your answer here, they will penalize you because you would have reported the displacement. Remember, the negative implies direction, right? So you have to actually really go down and answer the question. So this is worth 3 marks. Already we know where the 1 mark will go. So the fact that you have chosen the correct formula, they will give you a mark, and they'll give you a mark also for correct substitution. A mark here and a mark there, and that's a total of 3 marks. Now, before I jump to 3.3, I would love to welcome those who are new to the Scienceless channel and encourage them to please like and subscribe. And also do not forget to press the notification button. New content is coming every day. Now let's jump to question 3.3. In question 3.3, we are asked to calculate the time it takes the ball to reach the maximum height, right? So we want to know that how long will it take this ball to move from here to here, right? How long will it take this ball? The time it will take to reach the maximum height. I mean, at this stage we have a lot of quantities that we can use, right? But one formula that I'm going to use would be the definition of acceleration, where I say the final velocity is equal to the initial velocity plus the acceleration due to gravity times time, where I come and say my final velocity will be 0 because the final velocity, remember we're looking for the time from here to here, so the final velocity would be here, and then this would be my initial velocity, right? So the initial velocity here will be 5, -5, right? Plus here we have 9.8, right? Times changing t, right? I take this -5 to this side so that it becomes a +5 is equals to 9.8 times time. Then I divide both sides by 9.8 so that this side it cancels and I'm left only with the change in t, right? So this means the change in t would be equals to, this side I have a 5 divided by 9.8, right? And this gives me a time of 0.51 seconds. Now this is very important to update our information to say this here is the time 0.51 seconds, because remember from here until we get to 0, right, until we get to a velocity of 0 is the maximum height, right? Remember we are still here on answering our questions. Perhaps maybe one thing that I can quickly go there to do is the n, to explain what the n means. It means navigation of the answer to see if our answer makes sense, right? So if you look at our previous answer, is about 1.28 meters. That's slightly above a meter, right? It makes sense for a ball to move such a distance. Doesn't necessarily look like a long height, right, or even small, right? It's possible that if an object moves at 5 meters per second can reach that height, and the time is quite reasonable because it's not far. It can take a couple of seconds, right? Less than a minute really before it can get to that height of 1 meters, right? Another way in which you can navigate the problem is to change some of these parameters. Maybe increase this and look at if this will increase, right? Or maybe increase this and check how this height will increase or will it decrease, right? Obviously, if the initial velocity is higher, we expect to reach a higher height. If it's smaller, we'll expect to reach a less height. So look if that can be the case. If you don't see that pattern, there is a suspicion that our answers are incorrect. Maybe we've done some mistake when we're solving this problem, right? Then we'll jump to 3.4. 3.4 says, what is the velocity of the ball when it returns to the reference point? Now, this question is a very specific question. They don't say calculate, they say what is. Even the mark allocation here says 2. It means you have to just write the answer without doing any calculations. Now, when the ball returns to the reference point, they're referring to when the ball is here, because it will move away from the reference point, reach the maximum height, and return back to the reference point. They say what will be the velocity. We know that the velocity when it goes up is -5 meters per second, meaning it's going up. We expect the velocity here to be 5 as well meters per second, right? but it's going to be a positive one because remember it's going down now, right? So our velocity here would be, and I will say my velocity would be 5 meters per second downwards. Now this question is worth 2 marks. They'll mark you for writing the magnitude. Basically this is the speed, right, and the direction, right? Remember that the speed, the magnitude, the speed, this number here is the same as this number here, right? But the direction is different. That's why one of it is positive, the other one is negative. So the speed is the same, but the velocity is not the same. It differs with direction. We know this because projectile motion VPM is symmetrical. It has a speed symmetry. The speed that it takes to go up is the same as the speed it goes down with. We know that from symmetry. Now we'll jump into the last question that says, draw a fully labeled position versus time graph for the ball, right? Now I'm going to give you tips and the best way of drawing this graph that will make you to never go wrong in any exam situation you can enter. Now remember that if you take the equation, changing y is equals to initial velocity times time plus 1 over 2 g times t squared, right? Remember that the displacement here can be written as y final minus y initial is equals to I changing t plus 1 over 2 changing that squared. Now I'm going to rearrange this so that I take the y initial to the other side. So I'm going to be left with y final here, and I'm going to also rearrange this so that I start with this guy here. I'm putting him here in front. So I'll have 1 over 2g. I'm just rearranging here. Then I'll have plus vi change in t. Then we will have plus y initial. I want you to notice something here. This equation looks more like a standard form of a quadratic equation. So f of x equals to ax squared plus bx plus c. Now let's get down to this. The f of x here is the same as the y final, right? It's the same as the final position, right? So this means this guy here has the same properties f of x. It determines every point on the graph. It determines the y values, the values on the y-axis. Same thing with this guy, determines the position, the y-axis, right? The values on the y-axis. Now if you look at this guy here, the half and g, right, they represent the a here, right? They're the same as the a, and they have the same property of a. So meaning in our parabola, we know that a determines the shape of the graph, whether the graph would be a happy graph or a sad graph, right? Or a sad graph, right? That's what a will determine. And the t, we can see that the t is an x, right? T squared x squared, right, is the variable. It is the independent variable. It's sitting there on the x-axis, right? That's why when we plot our graphs, t is sitting on the x-axis. Now the vi would be the b here, right? That will be the initial velocity that we have in this case, and t, we talked about this x. Now the yi, the initial position, represents the y-intercept, where the graph will intercept the y-axis, right? So what I'm saying is that we plot position versus time graph using this equation. So one thing that we already have learned is that this graph should be a parabola in shape, right? It should be a parabola in shape, right? So when we plot this graph, let's go down and plot this graph. The first thing that we are going to do is to plot our axis to say we have, let me get a straight line here. We have the x, we have the y, and the x-axis, right? So on our y-axis, we said this will be our position y measured in meters, right? It is this guy here, the position represents any position, right? And on our x-axis, we said we'll have time, right? Is x measured in seconds. We have time measured in seconds, and definitely this is the origin where everything is 0, 0. Now, when we look at this situation, we already know that our g is positive in this problem because we said that anything that goes down should be positive, right? Anything that goes down should be positive. Our g is positive, and anything that goes up should be negative. The graph already told us that when we interpreted that. So this means our g here is positive. Our g here is positive. That means we will have a happy graph, right? So our shape that we expect is a shape that's sitting like this, a happy graph. But also one thing that you have to notice is that our y-intercept, the I initial here, right, is 0 because they said this graph started moving at the reference point at 0, 0, right? So our y here is 0. Our y here is 0 meters because the ball starts moving from the reference point. So it means our graph will start at 0. So the graph will start here at 0, right? And it definitely should have a happy shape. It should be a graph that goes like that because we know that it's a parabola, right? And this means at this stage here, that's where you will measure your maximum height. That's where it will reach the maximum height. And we know that the time, we calculated the time to be 0.51. So here we'll have 0.51 seconds. And this means the time here will be double that because we also have a symmetry of time. 0.51 by 2, this should give me 1.02, right? 1.02 seconds. Remember that the time it takes for the parabola to go up is the same as the time it takes to go down. So the time from here should be symmetrical, should be the same as the time this side, right? The time this side should be the same as the time this side. That's why here I'm doubling that time. And the other thing that is worth noting is that you have to notice that at this time here, our height that we'll have reached will be negative. We have reached a height of negative. Well, in this case, because negative means direction is the displacement, right? But in terms of height is 1.28. So it's going to be negative 1.28. So this would be negative 1.28, right? And it's measured in meters, right? I think we have put everything on the graph. Let's see if they said we should put, they just said we should put all the labels. Now the 5 marks for this graph would, one thing that I need to do before I can talk about marking this is that you have to write that this is a position versus time graph. Very important to put the title for your graph, right? Because they will give you 1 mark and 1 mark for putting the correct axis, 1 mark and 1 mark for labeling, putting these labels here, the correct coordinates of this graph, the fact that it starts at 0, that will guarantee you 1 mark, right? And it will give you 1 mark as well for the correct shape. Then that's a total of 5 marks, right? I hope this analysis of the graph in terms of drawing it using this guy here makes sense. This, we know this from mathematics, right? These are the properties of parabola as we know them, right? Stay tuned for the next question, question 4.